Today we're going to look at inequalities. We will start our discussion on inequalities by looking at linear inequalities. Number one, we shall look at linear inequalities in one variable. Number two, we shall also look at the combined inequalities. Number three, linear inequalities in two variables. Number four, graphical representation and region of solution set of inequalities. Now, the following symbols are used in inequalities: less than or equal to, greater than or equal to, not equal to, not greater than, not less than. Solving inequalities. The principles applied in solving equalities or equations are same in solving inequalities, except that multiplication or division by negative value changes the inequality symbol. Thus, 2 is less than 5. That's correct. But if we multiply both sides by a negative value, maybe minus 1, minus 2 now is greater than minus 5. You can identify that from your number line. Remember, this is a number line, this is a 0, maybe this is a point, and we're talking about 5 here, so to say. We have minus 2 here, let's say we have 2 here. The first one, 2, obviously is less than 5. But minus 2, assuming here is minus 5, is greater than minus 5 from your number line graph. So you can now see that 2 is less than 5, that's correct. But minus 2 is greater than minus 5 because the numbers are descending towards the left. 5 is greater than 2, 2 is greater than 0, 0 is greater than minus 2 is greater than minus 5, and so on and so forth. Let us take the first example on linear inequality. Solve the inequality s minus 1 greater than 4 into s plus 2. Our solution, you have here your s minus 1 greater than, open the bracket, that's 4s plus 8. Collect like terms, s minus 4s is greater than 8 plus 1. This becomes minus 3s is greater than 9. At this point, I'm going to divide both sides by minus 3. So this will be s. Because I'm dividing by minus 3, this symbol will change to less than. And this is 9 all over minus 3. So our final result is s is less than minus 3. You will recall that one other thing that is important in inequalities is that, especially linear inequalities now, is that we can represent this information on a straight line graph, the number line graph. And this is something like this. You have this as the s as this. Then there's a point here, which is the neutral point, 0. Then we mark off a point which is minus 3. And then, of course, we are told in this case that our s is less than minus 3. So on minus 3, we put that. Then you put a straight line here, and then you indicate the symbol, showing that it is what? Less than minus 3. Actually, the values we have here, if we are asked to list these values, we have that our s should be equal to minus 4, minus 5, minus 6, and it goes on like that. These are the list, or this is the list of values, and this is the range of the solution set. S is less than minus 3. You will recall in this case that the circle on minus 3 is not shaded because the symbol less than is strictly less than minus 3. So minus 3 is not one of the elements of the numbers that make up S less than minus 3. Take note of that. Example 2. The solution set of the inequality S into S minus 1 less than S plus 1 squared is given by that. Solution. Now you have S into S minus 1 less than S plus 1 all squared. You open the bracket, this becomes S squared minus S, and then when you open the bracket, that is also S squared plus 2S plus 1. You can now collect like terms. S squared minus S squared, I will have minus S minus 2S is less than 1. This will be 0. You have minus 3S here less than 1. Dividing through by minus 3, our S will be greater than minus 1 all over 3. And you can see represent this on the normal line graph. This is your S. Maybe this is your minus 1 over 3. And maybe 0 is somewhere there. Greater than, put the circle there. And you draw the R and then put it there. That gives you the number line solution or the graphical solution of this inequality. Example 3. If 3s minus 1 over 4 raised to the power minus half is greater than 1 over 4 minus s, we are required to find the value of s. Here we're looking at the range of values of s. Solution. You have your 3s minus 1 over 4 raised to the power minus half greater than 1 over 4 minus s. Now recall the laws of indices. This is 3s and this is 2 raised to the power minus 2 all raised to the power minus half greater than 1 all over 4 minus s. Eventually that is 3s minus 2 times minus half will give you 1. So this is 2 raised to the power 1, which is 2, greater than 1 over 4 minus s. The next thing now is to clear the fractions by multiplying all through every term by 4. So multiply by 4, so we now have 12s minus 8 is greater than 1 minus 4s. Multiplying all through by 4. Now that they have cleared the fraction, you collect like terms. 12s plus 4s is greater than 1 plus 8. And this is 16s greater than 9. So that your s is greater than 9 all over 16. If you have to represent this on a number line, you just mark a point there. This is your, let's say, this point is your 0. And then this point here, let's say it is 1. Maybe here is 9 over 16. 9 over 16. You have that. So you put your circle there and you draw and indicate what you have. That gives you the solution to the problem. Graphical solution, algebraic solution. The range of values therefore s is greater than 9 all over 16. Example 4, solve the inequality for which s plus 4 all over 3 minus s minus 3 all over 2 is less than or equal to 4. solution. As long as there are fractions involved, you need to take the LCD. The LCD here means the least common denominator is equal to 3 times 2, and that is 6. So multiply all through by 6. So 6 will multiply s plus 4 all over 3, and 6 will also multiply s minus 3 all over 2, and 6 will also multiply the 4. 3 will cancel 6 is 2, so you have 2s plus 4, and 2 will cancel this is 3, you have s minus 3, and less than or equal to 24. Now open the bracket, that is 2s plus 8, and that is minus 3s plus 9, less than or equal to 24. 2s minus 3s is minus s, and less than 24 minus 17. So minus s is less than. If you subtract this, you have your 7. So your s will be greater than or equal to minus 7, dividing all through by minus 1. And so at the end, if you have to draw your number line, then you can indicate here as your minus 7, and then you put the circle, and then you draw your arrow in that direction, you put the greater than sign, and then you shade this circle. This indicates that the value minus 7 is part of the solution. So if you are looking for the least value here, you start from minus 7 and it goes like that. From minus 7 to minus 8, or greater than minus 7. So minus 7, minus 6, minus 5, and so on and so forth. So minus 7 there is the least value in this case. The question number 5, list the integral values of s which satisfy the inequality minus 1 less than 5 minus 2s less than or equal to 7. Integral means whole numbers. And of course, this is an example of a combined inequality. We will take the first part of it, minus 1 less than 5 minus 2s. Collecting like terms, minus 1 minus 5 is less than minus 2s. This gives you minus 6 is less than minus 2s. Dividing both sides by minus 2, you will have 3 here. The symbol now will change, and then you have s. In other words, our s is less than 3. You take the second part, 5 minus 2s is less than or equal to 7. And of course, minus 2s is less than or equal to 7 minus 5. And so, minus 2s is less than or equal to 2, giving you s greater than or equal to minus 1. In other words, our minus 1 is less than or equal to s. Combining them, you discover now that we have minus 1 is less than or equal to s, and s is less than 3. Now, if you draw a number line to represent this information, you will discover that you have minus 1 here, you have 0 there, you have 1, you have 2, you have 3, and this is the number line. And you are told that minus 1 is less than or equal to, so this is the region of solution. And then here it's a 0. You can combine the line, combine the straight line, joining them together. Alright? So you have your answer from the answer, therefore, will be minus 1, 0, 1, and 2, because 3 is not part of the element or solution to this problem. So our actual answer, the integral values are minus 1, 0, 1, and 2. We shall look at the graphical solution of inequalities in two variables. First of all, I want you to note that broken lines like this are used to indicate lines that are strictly less or greater than. Something like this, less or greater than. Why thick lines of this type are used for greater than or equal to or less than or equal to inequalities. Our interest here is to show the region that the solution resides in a graph, as we are going to see shortly in the example I will want to solve for you. Let's take the first example. And this one says, find the inequality which represents the shaded portion in the diagram below. Here is the diagram on the S and Y axis. Assuming this is the shaded portion, this portion is shaded. And they are told to write the inequality representing this area, this region that is shaded. You observe that this line is a thick line, and this is the equation of this line. Therefore, to find the inequality representing the region shaded, it means we have our 2s minus our y minus 2, which is the equation of this line, will be either greater than or equal to or less than or equal to. In this case, below the line is less than or equal to. Above the line is greater than or equal to. Therefore, the solution set will become less than or equal to 0. In place of that equality, the region is represented by less than or equal to 0. If it were the other side, the upper side that was shaded, then the inequality symbol would be what? Greater than or equal to 0. Please take note of what we have just done. Example 2. Here is the diagram. You can see the diagram given to you. There is a straight line, and below the straight line is shaded. You are asked, or you are told that the shaded area in the diagram above is represented by what inequality? That's exactly what they are asking for. Now, our solution. If you can recall the equation of a line, the equation of a straight line, if you recall that, is of the form y equal to ms plus c. The c, first of all, is the intercept on y-axis. And the intercept on y-axis here is 6. Y, the m, stands for your gradient. So y is actually equal to ms plus 6. Now what then is the value of m? Our m is the gradient. And how do you calculate the gradient of a line passing through two given points? So you use y2 minus y1 all over s2 minus sy. Now these points that I have used are 2 and 0, s1, y1, 0 and 6, s2, y2. So if we substitute them accordingly, our y2 is 6 and our y1 is 0. Our s2 is 0 and then our s1 is 2. When you solve this, you have 6 all over minus 2, and that will give you minus 3. So you can now write the equation. Therefore, the equation is y equal to minus 3s and then plus 6. So if we are to write the region where the solution lies, below the line is the one that is shaded, and we have a thick line. Therefore, you can write that the solution is represented as y plus 3s minus 6, bringing all of them to one side, is less than or equal to 0. So this is the solution set of the region that is shaded. Take note that this has to take us to writing down the equation of a straight line, which you should have studied in coordinate geometry. Now we'll take a look at another example 3. Here is a diagram for you, and you have a triangle that is shaded or dotted in this case. Now with what you have, this line is 2y minus s minus 2 equal to 0, while this line is y plus 2s plus 2 equal to 0. There is a region that is bounded by this line, and this line. They now want you to write down the solution of the linear inequalities of triangle SPT. What are those equations of those lines that are bounding the triangle SPT? Our solution, we take the first, take note that this horizontal line, the equation of the horizontal line is y is greater than or equal to 0, in the sense that above is shaded, below was not shaded. So the first inequality is y greater than or equal to 0. The second inequality defining that region is this one here. You observe that the equation is already given to you, and that is y plus 2s plus 2. The equal to is because of the line, but below is shaded, so the region lies below, so less than or equal to 0. Then you take the third one, and the third one is this line, and the equation is 2y minus s minus 2. Below the line is shaded, so less than or equal to 0. These three combined inequalities define the triangle SPT. These are the exercises for the inequality we have just treated. Number 1, solve the inequality 2 into s minus 3, close the bracket, less than 3 into s minus 1. We have the options A, B, C, and D. Number 2, for what range of values of n is n minus 1 over 3 plus n plus 3 all over 7 greater than or equal to n minus 2? You have options A, B, C, and D. Number 3, find all the values satisfying the inequality minus 11 less than or equal to 4 minus 3s less than or equal to 28. You have options A, B, C, and also D. Number 4, represent the solution of the simultaneous equation, inequalities, 2h minus 2 less than or equal to y, and 2y minus 2 less than or equal to s graphically. Number 5, here is a diagram and a shaded portion of the diagram. We want you now to find the region defined by the triangle OPQ. So say write down the solution of the inequalities defined by triangle OPQ. This is your O, P, and Q. The equation of this line is y minus s equal to 0. The equation of this line is y plus s equal to 0. And the equation of this line is s plus 1 equal to 0. Here are the answers to the exercise. Number 1, option A is correct. Number 2, option A, correct. Number 3, option C. And question number 4, this is the diagram representing the solution set of the inequalities represented. You can see the region that is shaded. Number 5, the line PQ is s plus 1 greater than or equal to 0. The line QO is y minus s greater than or equal to 0. And the line OP is y plus s less than or equal to 0. These are the three inequalities defining the triangle OPQ. Q.